Hey everybody, welcome back. So we've got 3 videos, 3 days in a row. And today we're going to be talking about natural language processing, or NLP. And what we'll be using to demonstrate NLP is the NLTK Python library. Natural language processing, or NLP, is a field of artificial intelligence, or AI, that focuses on enabling computers to understand, interpret, and generate human language. It involves the development of algorithms and models that allow computers to process and analyze large amounts of natural language data, such as text and speech, in order to extract meaning, sentiment, and intent. NLP is used in a wide range of applications, including language translation, sentiment analysis, chatbots, information extraction, and text summarization. So I just mentioned sentiment analysis, and this is also known as opinion mining. It's the process of using natural language processing and machine learning techniques to determine the sentiment or emotional tone expressed in a piece of text. Commonly used to analyze customer feedback, social media posts, and reviews to understand people's opinions, attitudes, and emotions towards a particular subject. Tokenization, on the other hand, is the process of breaking down the text into smaller units called tokens, which can be words, phrases, or symbols. The main goal of tokenization is to divide the text into meaningful units that can be used for further analysis. For example, tokenizing the sentence, "I love this product," would result in the tokens I and love and this and product and the exclamation point. Part of speech tagging, or POS, is the process of assigning grammatical categories such as noun, verb, adjective, etc. to each word in a sentence based on its syntactic role. Part of speech tagging helps in understanding the grammatical structure of a sentence and is used in various NLP tasks such as parsing, information extraction, and machine translation. And finally, syntactic parsing, also known as parsing or syntax parsing, is the process of analyzing the grammatical structure of a sentence to determine how its components, words, phrases, etc., relate to each other. The goal of syntactic parsing is to create a parse tree that represents the syntactic structure of the sentence according to formal grammar. This parse tree shows how the words are grouped into phrases and how these phrases relate to each other. And another way to think about this is sentence diagrams, or word diagrams, that we did back in grade school for our grammar classes. So in summary, these 4 techniques are fundamental in natural language processing and are used in various applications to understand and analyze text data. So let's take a look at our code. So at the beginning, we have a sample text, "John saw the man with a telescope," and we're going to break this down. So first we'll look at our sentiment analysis, we'll look at tokenization, where we tokenize the sentence, the part of speech tagging, and the syntactic parsing. And what the code will do is it'll display the results for each category. So when we look at the sentiment analysis, it gave us a score of 1.0 for neutral. Positive was 0, negative was 0, and compound was 0. Now for the tokenization, it took the sentence apart and it tokenized each of the words. So John saw the man with a telescope and a period. So the part of speech tagging, you look at each of the words that were tokenized. For the part of speech tagging, we look at the words that were tokenized above, and there's an extra layer of analysis that's done. So John is NNP. It's a proper noun singular. Each word is assigned a different tag as part of its speech. So saw is the verb past tense. The is the determiner. Man is noun singular or mass. With is a preposition or subordinating conjunction. A is a determiner. Telescope is a noun singular or mass. And the period is just a period. So with syntactic parsing, it did the same thing as the POS tagging, but now it's broken down the sentence into a diagram. And in this case, because it's in the terminal, it's not as clean as if it were to be drawn in. So for the syntactic parsing, we have the same type of tagging that's taking place in the POS tagging, except this time it's drawing a diagram. Now the diagram isn't very clean. It could be moved around a little bit so that it looks a little bit more, in line from, top to bottom. But in this case, it was just kind of a quick and dirty. So here's a cleaner version of that syntactic parsing chart that I was talking about. So that's it for today. If you have any questions, please reach out to me, leave a comment below, and I will see you all later.